Hi viewers, this is Sri Ramlu. So today's topic is uniform plane wave equation. Uniform plane wave equation. So what is the uniform plane wave equation? The wave equation for which electric field is independent of y and z and is a function of x and t only. Such a wave is called uniform plane wave equation. Here uniform plane wave equation means it has to depends only x and t and does not depends on y and z components. So it is a function of time and x distance only, not function of y and z distance. That wave equation is called plane wave equation. And here Maxwell's equations in free space are given by del dot E is equals to 0. These are the differential form. Del dot B is equals to 0. Del cross E is equals to minus dou B by dou T. Del cross B is equals to mu naught epsilon naught into dou E by dou T. And this equation also we can write like this also. Del cross H is equals to epsilon naught dou E by dou T also we can write. Why? Because B is what? B is equals to mu naught into mu into H or mu naught into H. And if you bring this mu naught this side, it becomes B by mu naught. So B by mu naught is equals to H. So here if you bring this side, B by mu naught, that is simply H. We can write in terms of H also. Now taking curl on both sides of equation 3. See, this is the equation 3. Take it both curl on both sides. So this side curl is taken, this side is curl is taken. Curl means del cross. Del cross is simply curl. Okay. And multiply this curl inside. Then we can write like this. B minus here outside. Okay. And already del cross B is what? See, del cross B formula from equation 4. Del cross B is mu naught epsilon naught dou E by dou T. This is okay. And now next step. So del cross substituted and multiply this dou by dou T inside. Dou into dou, it becomes dou square. Dou T into dou T square. And the remaining these and minus are same as T's. Now formula for del cross E. So del cross A formula is del into del dot A minus del square A. Once again, if when A is vector quantity, then del cross A is equals to del into del dot A minus del square A. So here in the place of A, what you have? E you have. Just replace A by E. Then see, this is the formula. Del into del dot E minus del square is equals to minus mu naught epsilon naught dou square E by dou T square. Okay. And already we know this formula, this term is 0. Why? Because see, first equation. See, what is the first equation? Del dot E is equals to 0. That is substituted here only. Okay. So here this value is substituted. Then this term is 0. Then we can write it is like this. Now minus gets cancelled. Now it is the final answer. Okay. So del square E is equals to mu naught epsilon naught dou square E by dou T square. Okay. This equation, this is the wave equation in terms of E. Okay, it is in terms of E. In terms of B also we can write like this. Simply replace E by B. But with equation by, similarly we can derive this wave equation in terms of B using equation 4. But this equation we derived with equation 3. If you want to derive this equation, you have to use equation 4. Okay, it is by using third equation. And if you want to derive this, you have to use fourth equation. Then you can get the same process. If you want to do, you can do. Okay, from first equation. So I told you, I have shown you also. Del dot E is equals to 0. Yes. And del formula is this: I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Dot E is a vector quantity. I ex Iey, Jey, Kez. Here X, Ey, Ez are the components along XYZ axis. And the dot product, you know how to do the dot product. So simple multiplication. Just multiply I coefficients like this, J coefficient like this, K coefficients like this, make it equals to 0. Okay. In the definition, what I said, plane wave equation, for a uniform plane wave in which E is independent of Y and Z. So E cannot depends on Y and cannot depends on Z. It depends on only X and T also. X and T. Okay, so then when it is independent, then dou Ey by dou Y is equal to 0, dou Ez by dou Z is also 0. Substitute these two terms in this equation. Here 0 and here 0, then this is also equal to 0. It means here, when dou E by dou X is 0 means when it is constant, then only differentiation is 0. So Ex is constant. So along X direction, electric field is constant. Equation 7 shows that there is no variation of Ex in X direction. Along X direction, no change, no variation. Therefore, uniform plane wave equation, uniform plane wave propagating in X direction. Okay, it propagating in which direction? X direction only, not in Y direction. X direction and has no components of E. Similarly, there is no component of B or H in X direction. Why? Because E and H or B both are no changes along propagation direction, that is along X direction, but these two changes along Y direction and Z direction. Therefore, uniform plane electromagnetic waves are transverse and have component of E and H only in directions perpendicular to the direction of the propagation. Okay, so when the wave is propagating in this direction, okay, let it is X direction, it is Y direction, it is Z direction, and electric field like this, and then magnetic field is in this direction. Magnetic field, if it is Z direction, electric field is in Y direction, but they cannot change along X direction. They changing along Y and Z direction only, and no changes along X direction. That is the meaning of this. So such waves are called plane waves or uniform plane waves. Okay friends, so this is the today's class and a very short video. Thank you.